Hello guys, welcome. This is your very first episode in this course. In today's episode, we will dive deep into advanced techniques when dealing with Kotlin functions. By the end of the session, we'll cover the following types of functions. We'll look at local functions, inline functions, infix functions, and anonymous function. First, we'll start with local functions. Before that, we need to ask ourselves, why functions? Functions are a block of code that can be reused by different portions of a program. Functions are a concept that are not unique to Kotlin. They are available in numerous other programming languages such as Java, Swift, Go, Ruby, among others. Kotlin usually offers a Fluent API for the reuse of function within your code. One of those options is the ability to nest functions within others. Ideally, a local function is a block of reusable code that is declared within another block of reusable code. Let us look at this example here. Firstly, let us create a function known as properties. We'll use this as an illustration of a rectangle that has a length and a width of a certain value. We'll need to provide its area and its perimeter. Local functions will be functions that will be nested inside an existing one. So we could have a function that calculates the area. Another thing we could have is our perimeter function. With area and perimeter, we have our two properties. We can return these values inside our bigger function. We can see our function known as properties can have other functions within them, the area one and the perimeter one. This is valid syntax in Kotlin. Let us try to use some example here. We could print our properties, and this will just be our properties function. We can provide our length and our width. Let's have 12.5 and 36.7. There we have our result. Contrary to other functions, all local functions must be defined before they are used in your code. Kotlin does not allow you to use a local function that has been defined below its usage. Let's take another example. Assuming we have a function that will calculate the maximum possible sum between two integer numbers. Let us assume that these numbers are both nullable. Let us also return a value that is non-nullable. Let us declare a function. Let's call it isValid within the maxSum function. This will return a boolean. We'll just use this function to check whether either of these numbers are null. Let us assume we can only perform arithmetic operations on non-integer numbers. Therefore, if either of the numbers is null, then we might as well not have a maximum sum. Next, above it, let's try to use this function. We could have our maximum sum being stored in a variable called num, and we can check if this is valid. Probably return the maximum possible integer, else just give it a 0. Try to return this value. As you can see, our IDE is already complaining that it cannot identify this function called isValid. This is because local functions can only be used after they have been defined. Therefore, if we lift this out, place it at the bottom, we can even simplify this expression, inline the variable. This will now work. This can compile successfully. There's a strong allure to increase your level of abstraction with local functions, but there are some few things that may deter you from abusing them. One of them is reduced readability. When local functions are used extensively within another function, it can make the code harder to read and understand. This comes also with limited visibility. Local functions are only visible within their enclosing functions. This means they cannot be accessed or called from outside the function, which can be a limitation in certain scenarios where reusability or external access is required. If the functionality of a local function needs to be shared across multiple functions or classes, you would be required to extract and make it into a separate function. Each time a function is called as well, including local function, there's a small performance cost associated with setting up the stack frame and allocating memory for local variables. While this overhead is usually very negligible in most cases, excessive usage of local functions within a loop or in a performance critical scenario of your code, it could have minor impact on overall performance. This also includes an additional size in the number of functions or methods available in text files. This can be a deterring issue when building Android applications. A certain number of functions or methods are allowed within them. Local functions will increase the number that are in there. There's a high chance of code duplication. Local functions may be repeated within other functions due to their limited visibility. And there's also increased coupling. For instance, this area function can only be used within properties, nowhere else. These two functions are heavily dependent on each other. Throughout this course, we will build a story around an animal farm. To get started, I want us to create an animal abstract class. This class we'll use to define different properties and behaviors that our animal can make. From there, we will extend the usage of this animal class into what our farm can do. Firstly, we can comment all this out or delete them entirely. For my case, I'll just remove them. Let's also remove the usage in main. The first thing we want to do is to define the abstract class known as animal. This class will take in one parameter known as name, and it will be the name we give to each animal that we create. The next thing that we want to do, we want to define some animal properties. This will include the number of limbs that an animal has. We can check whether they are cold-blooded or not, and even the sound that they make. I've made the sound a nullable string simply because some animals don't have natural sounds that they make. A good example would be fish. Let us define some animal behaviors. There will be two main behaviors that we'll use: making sound and movement in a certain direction. This, of course, might change over time as we explore different parts of our Kotlin functions. We'll start with the function known as makeSound. Within this function, we can add a local function. This local function will be known as customSound. Let us have this customSound function return a string. We'll have a single return expression to check whether the sound is blank or not. I'm allowed to not use parentheses since this will be a one-liner. It's not make sound. Else, we will just say B specific animal is doing this specific sound. There we have it. Lastly, in this makeSound, we can just print out the value. Great. Next, let us define our move function. We'll take in one parameter that will indicate the direction, and then we'll provide a statement as to which direction the animal is moving. I'll use a string literal, and let us assume this is your animal. So my whichever animal I am is heading towards the direction. Our abstract class is now defined well and good. We've got our limbs, whether it's cold-blooded or sound as the properties, and two functions, make sound and move. The next thing we want to do, we want to start exploring different animals in our farm. The one animal I do have is a fish. This is because I have a fish pond. Let's create a new fish class that will inherit our animal class. Next, we will import all the necessary properties. Fish don't have any limbs, so we'll equate that to 0. All fish are cold-blooded, so this will be true. And fish don't have dedicated voice boxes. We want to make sure our two animal behaviors can be inherited. Therefore, we'll make them open. Now, let's make some sound. I want my fish to be a trout. Create a new fish object. Next thing, we'll call the make sound method. Once we run this, you'll see that the fish does not make sound. Great. The next thing we want to talk about is inline functions. Before getting into the details of what inline functions are and how they work, we can look back at a popular concept in Kotlin and functional programming languages in general. Kotlin can be classified as a functional programming language based on the following features that it supports. 1. Higher order functions. Higher order functions are functions that are treated as first-class objects, meaning they can be passed in as parameters as well as be returned in other functions. They have support for inner functions in Kotlin. Functions can be defined within other functions. Similar case to our custom sound function in our example. Thirdly, functional programming languages support lazy evaluation strategies. This can be witnessed in things like Jetpack Compose composition mechanisms, let init variables in Kotlin, asynchronous tools found within Kotlin coroutines, among others. Higher order functions have paved way for writing idiomatic Kotlin code, while allowing us to pass in functions as parameters and also returning them as values. When your Kotlin code compiles, functions are turned into execution objects that are stored in memory. This is also the same case for classes. If you create a new function that receives other functions, or in this case, what we popularly know as lambdas, they will be computed as an execution object during compilation. Extended use of such functions in your code can cause compilation overhead. Inline functions allow us to reduce this kind of overhead during execution, since each execution object has some memory allocation associated with each. An inline function will pass the required action or set of actions as part of its execution call stack. This means all the code in the function will be considered as actual lines in the calling block. Creating an inline function simply requires one to add the inline modifier before the function definition. This will result in larger lines of generated Kotlin bytecode. However, it will provide a much smoother approach to memory allocation as opposed to regular functions. It is important to remember that the modifier will work on the function itself and all the lambdas passed along with it. When used reasonably, inline functions will pay off in performance, especially in megamorphic call sites. However, if you do not want all the lambdas passed to an inline function to be inline as well, you can mark some of your function parameters with no inline modifier. Let us look at what we mean. Assuming our animals have to communicate. These animals might have a message and the time in which they want to communicate it with. Let's put this outside of our current class definitions just for demonstration purposes. We'll have the message being passed in as a lambda that doesn't return anything. The next thing is the amount of time that this message will be communicated along with. Let's make that a long. We probably could be wanting to know when the message has started coming in. Then we can call the message itself. And then lastly, tell how much time was taken to process that message. There we have our current communication. This is a regular function that intakes two other functions. Both of them are lambdas. One will contain the message itself. Two will be the time in which the message was executed. When the function is called in this manner, what will happen is our main function will create a trout object, store that in memory. It will call the make sound, store that in memory as well. Communicate will be stored in memory as an object. This message function will be stored in memory as another object, and the time will be stored in memory as another object. As your lambda functions continue to grow, the memory allocation for each continues to grow as well. However, If we mark communicate with the inline modifier, the inline modifier will make the Kotlin compiler to generate the following type of code. It will have 3 individual print lines as opposed to 3 different memory allocated processes. This will result in larger Kotlin bytecode. Take that in mind. However, the performance overhead is greatly reduced because there is no need to allocate memory for each of these 3 actions. You can add the no inline modifier to the lambda that you do not want to be regarded as an inline function. This is because inline functions, once indicated at the function definition, will make all the parameters inline as well. If you do not want to have one as inline, add the no inline modifier. This will make sure that the time function, in our case, will not be considered as an inline function. Kotlin offers a very pragmatic way of making code look and feel very concise. A big part of concise code is readability. Readability of code has been one of the driving factors of functional programming languages. And if you have ever written an application using Ruby, then you have experienced readability to a whole new level, almost close to human-like language. Kotlin has features that allows us to create very readable code within our application. One of the easiest ways to do this is by the use of infix functions. Kotlin functions prepended with the infix notation can be called without the need of brackets or periods. They make your code look more like natural language. A common use of infix functions within the Kotlin standard library is the inline map function. This usually has the to function, which creates an association between a map's key and its value. Pairs and triples also use this infix function as well. Another popular use is from our bytes, shorts, longs, and ints. They all have defined bitwise operations, such as the AND operator, OR operator, XOR operator, among many others. All these bitwise functions are also defined as infix functions. In order to create your own infix function, you need to adhere to the following 3 rules. 1. It must be defined inside a class or be an extension function to an existing class. Infix functions cannot be run independently. Number 2. The function must be prefixed with the infix annotation. Lastly, your function must contain only one parameter. Let us continue playing around with our animal farm. Let us add another property known as gestation. We will measure the gestation period of these animals in months. Since certain animals would have a gestation period lower than 1 month, I'll make sure the gestation period is a double. Let us override this property inside our fish class. Since there's a wide variety of fish and their gestation periods are very varying from 3 weeks all through to 5 months, let's put a value that's in between. Something like 3 months. Our gestation period should not be now. Let's just remove that. Let us add another animal. Outside of fish, I could be having some mammals in my farm. Let us create a new mammal class. We can import the animal abstract class, provide the mammal parameter. We can override the different values. I'm assuming my mammal for today is a cow, so let it have 4 limbs. Mammals are all warm-blooded. Since this is a cow, it will moo. Ensure it is non-nullable. Cows have a 9-month gestation period. Great. Let us now introduce another function. This function will allow us to crossbreed 2 different animals. Maybe a fish and a mammal, maybe a fish and a reptile. Depends, who knows. To create an infix function, you need the infix notation. Provide the function definition. We are crossing 2 different animals. Next, you need to know which 2 animals you're crossing with. So 1 is the breed you want to cross against. It will be of animal type. Let's not give it any return value. We just want to show up some message. Let us create another local function. This local function will check whether the two breeds are of the same type. If they are, then the gestation period will remain the same. If they are not, the gestation period will be a summation of the two. That may not be what happens in real life. However, this is our animal story. If the two names are the same, we'll assume they're the same breed. Instead of having it as a string, let's use it as a double. We can have the value and then outprint something else. If they're the same, we can just pick breed.gestation. Else, we can have an addition of the two. Amazing. Lastly, let us print out a message. Great. We now have a function that allows us to cross two animal breeds. Let us see how we can use infix functions without the need of the dot operator nor the parenthesis for putting in parameters. Firstly, let me make another animal. In this case, our cow. Our cow is a mammal. And then lastly, let us cross the cow with the trout. To do that, since it's an infix function, our cow object will just provide a space. Then we'll provide the cross method. And then lastly, the breed that you want to cross it with. I'll cross it with my trout. With this, we can run our main function. There we go. The fish and mammal will give an offspring after some 12 months. An anonymous function looks very much like a regular function declaration, except the name is omitted in the function signature. Its body can either be an expression or a block. Let us look at an example. We can create a new variable known as calculate. This variable will be an anonymous function. How we define it as an anonymous function? We'll simply provide our fun keyword, provide your parenthesis, and then your function block. This function can take in two properties, maybe A and B, and we will sum them. We'll have the return of a long. The parameters and the return type, as you can see, are specified in the same way as that of regular functions, except the parameter types can be omitted if they can be inferred from the context. Let us take a small example of some random numbers. Assuming you want to find the very first negative number, you can define how the behavior of the very first negative number can be found using an anonymous function. Take, for example, we can have the find method, which usually takes in another function that requires an integer and a boolean as the return type. We can omit the types when declaring our anonymous function. How do we do that? We'll have fun. We'll expect a num, leave out the type. We can have it result in checking whether num is less than 0. This code will fully compile, regardless of us not putting in any sort of types within our anonymous function. We can store this into a value. And lastly, we can print this out. First negative number. If we run this, we expect our very first negative number to be negative 23. There you go. Anonymous functions with expression bodies similar to ours do not need the return type. However, similar to normal functions, the return type must be indicated in the event you use a block body. For example, if we converted this into such, this would not compile. This is because if the anonymous function does not have an explicit return type with a block body, then the code will not compile. You must declare the type. And indicate the return. Lastly, when passing anonymous functions as parameters, place them inside parentheses. The shorthand syntax that allows us to leave the function outside the parentheses only works for lambda expressions. Amazing. I hope you found this very useful for your own usage and how you can explore much more advanced functions within your Kotlin workflows. In our next episode, we will discuss tail recursion, lambda extensions, instance invocation, and operator overloading. See you then.